Hello, and welcome back to the Science Fair series. Today we're talking about data handling. This is episode 2 of the series. Now, it's important that you saw episode 1, so make sure you've seen that before you go on. Last time we were talking about the central tendency of your data and what that means. It means we were using darts to describe it, where in the center of your data is the mean, median, and mode, and we talked about that a little bit, and then the distribution of data, what it looks like, and using terms like accuracy and precision in order to describe the distribution of the data. Today, we're going to talk about playing with Excel and deciding which graph type to use to display your data. Before we do that, I want to show you how to increase your functionality in Excel. As Excel comes, some of the functionality that it has in it isn't necessarily turned on. So in order to do that in Excel, go to File up here, go down to Options, and go to Add-ins and go to the Analysis Toolpack. Okay, click on that. And then down here where it says Manage Excel, click on Go. And then last time you have a check mark here. This is all default. Analysis Toolpack, just confirm and then click on OK. And now in your data ribbon, you have a new component called the analysis, data analysis. So just to show you a little bit about how to use that, remember last time we were talking about different series, different types of series, right? So we have this series of data sets. This one's data set 1, data set 2, and so forth. And how the distribution of the data among them changes values like your standard deviation, right? And how the mean, median, and mode changes with the distribution of the data. So like, for example, this series, all of the values were 8, right? The mean, median, and mode were all 8, and that doesn't really tell you about the data distribution. Like the standard deviation is 0, which means there's no spread. Everything's the same, right? And then you have some more series that have more data in there from zeros and twos to 16s and eighths, right? And you can see that the numbers are still the same. The mean, median, mode's still the same, and the minimum, maximum, are datas, but the mean, median, mode are still the same. But you can see that your distribution has changed quite a bit. Your standard deviation, so you can see your distribution. And then we were talking about some where the distribution is a little uneven, right? But here we had the same number of low numbers as we had high numbers, but over here in 6 and 7, this one we had more low numbers than we had high numbers, and we looked at the distribution, right? So, but the mean, median, mode are more important over here, right? Because now you can't tell the difference between the distribution, but the mean, median, and mode had changed. And this talks about the skew or and we'll talk about skew more on the next time. But anyway, just playing with data is a lot of fun. So what we have over here is another way of looking at this data. So here's the data values. Like for example, all of these have zeros, twos, fours. Some of them have 0, 2s, 0, 4s, right? But zeros to 16. And then we count the number of items. Like for series 1, there's 20 items, but they're all 8, right? In series 4, we have 1 0, we have 2 2s, right? In series 4, 1 0, 2 2s, 3 4s, right? 4 6s, 4 10s, right? No 8s, right? So we just counted the numbers of each time, and then we can do other types of graphs just to show you. Okay, so kind of refreshing our memory about the different series that we talked about last time, let's play with some of the statistics. So let's go to descriptive statistics, and we'll hit OK. And the first thing it's going to say is, what data set do you want to use? And we'll just go grab our data. So we'll grab all of our data like that, right? And then make sure you hit new worksheet. I like to put all the graphs on a new worksheet, and then just hit OK. Okay. And you'll get all the statistics. Now, a couple things. That column that we had in here that was empty, right? This one's empty. It's going to have a bunch of errors in it. See, all these are errors. And so we'll just delete that column so it's not confusing. Okay. Now, a couple other things. First thing you'll want to do is clean up how to look at it, right? So we increase the size of the columns. Now for this first one, right, it doesn't know how to calculate skew because all the values are the same. So it's like dividing by 0. You can't do that. So you'll get errors like that if your data looks like that, but that's just fine. It's just telling you that it can't calculate. The other thing that it'll do, has all these decimal points. And so let's clean up what that looks like. So go to Home, go to Format, Format Cells, and click on number because it's a number. And now we're going to tell it that we just want 1 decimal point because we're just using 1 decimal point. Remember, in our target, we only had 3.1 or 4.1, 1 decimal point. So we'll continue that. Hit OK. And now this data makes sense, a little bit more sense. You might not have seen in the past data that had e's in it, like that did. And let's see if any of these have any more of these have. No. So if I just unclick that, right? So here, just to show you real quick, this data that has an E in it, you might not have never seen a data with E in it, and that just means that if it's an E with a minus next to it, it's a very small number, and if it's an E without a minus, then it's a very large number. But it doesn't matter. All we can do, we can just create it so that the decimal points are just 1 again, and then a very small number just turns into 0, and that's easy to read. Okay. So now we've done some descriptive statistics. We've calculated our mean, median, mode for all of our data set. We can talk about standard error in the next one. We talked a little bit about deviation. It calculates that. Variance is just another deviation. Of course, skewness that we'll talk a little bit more about next time. So that's just how to create some of your data sets. Another way of creating is called a histogram. And that's the same thing as really the bell curve that we were doing. And so you can create bell curves out of your data. So go back to your analysis pack and we'll go down to a histogram. Hit OK. And we'll select a data set. And for example, this one is pretty interesting, right? Because it has a nice big span of a bunch of different numbers, right? And then the bin range is the value range that you want to use. You want to use all the zeros, 0 to 18, 0 to 16, right? And put it in a new worksheet. Make sure you click chart output on the histograms and then hit OK. And you can see there's your histogram. Of course, you can do that for any number of the histograms, like for the first one, right? The series is, so we'll go back to that, hit histogram, say OK, except for this time we'll get our input is instead of this column, we'll go to this column, right? And we'll hit OK. All the other settings are the same, and there's histogram, right? It just shows that there's one thing, all the other values are 0. Of course, so that's not quite as interesting as the last one where we had a bunch of different values. Okay, but the thing about both of them is that the center tendency is the same, right? Right smack in the center, there's the biggest part of the bell, right? If we were to draw a graph around it. So let's go back to here and we'll get another one, go back to our data analysis, our histogram, and we'll get one of these where we had where the center tendency isn't 8 anymore, right? Where the median isn't 8 anymore. Now it's skewed to one side. It's called skewness. So, now we'll go to collect a different series, okay? And we'll hit OK. And so now you can see that your graph, your center tendency isn't in the center tendency of your data isn't the center of the graph. So that's called skew. And we'll talk a little bit more about skew again on the next one, but this is just to help you to figure out how to graph some of your data. Some other things that you can do is you can create just bar graphs. So if I go and select a series over here, and so this when you do the bar graphs or histograms from the just the standard set that Excel offers, instead of the histogram over there in the data histogram, it's a little more complicated to do, but so we can just still go to collect the data and it shows it, right? But I had to count all the values, right? So I had to count all of the value. So this is the values, right? The count. But I can still go and do these. I can put in another one, right? Insert another bar graph. I'll go to this one, right? And hit the bar graph, right? And so that's the same thing as the histogram we were looking at before, except for, again, I had to create the second listing by counting the values over here. But the one thing you can do over here that you can't do in the histogram is create a smooth curve. So if I go to insert, right, and here, if I go to this one here, which is called the scatter curve, it will create the curve, basically the bell curve there. and it'll show you that it's the skew is to one side. Okay, so that's just playing with Excel. Let's get back to the presentation. Of course, there's lots of other things you can do, bar uh, graphs, and there's of course pie graphs, which are, and we'll talk a little bit about how to choose graphs in just a minute. Okay, so there's a nice, oh, I forgot to show you, a nice cool resource that I have here. Click, it's from the Indiana or Illinois Institute of Technology, and it's a nice data analysis page right here. That is right on the PowerPoint that right here. Okay, nice resource. Okay, next. Oh, stand by. Okay, so we went and played already. So let's talk about histograms and measures of skews. Now we were just talking about the bell curves and what skew is, right? So a possible graph to use to display your data is a histogram, right? So we talked about histogram, and here's the right, the ones with the center tendency being in the center of the data is the same place in the graph, and here's one where the center tendency is in a different place than it's the center of the graph. Right? So we'll talk about skew on the next one. Another way of describing your data is a scatter plot. Scatter plot and correlation. So correlation is a statistical technique used to determine whether there is a significant relationship between two variables, right? Your x and your y axis. So if you're changing your independent variable and you're measuring your dependent variable, you can show the relationship of those by creating scatter graphs, and you can see whether there's a strong correlation. Oops, where they have an alignment along the line, or a weak correlation, but they still have some correlation, and whether it's positive going up or negative going down. Okay. Another way of showing your data is called box and whisker plots, and it helps you display your maximum and minimums of your different types of data. Another way of showing displaying your data in your science fair project is line graph displays connected by points in a line, often representing a change in time, right? So if you have a change in time, you're showing the growth of a plant, for example, or the speed of a chemical reaction, then line graph is very good. Of course, we talked a little bit about bar graphs. The interesting thing about a bar graph, different than a histogram, right? A histogram uses quantitative data, which means like gallons of milk or gallons of water. And I think we didn't really talk about that here. So one of the things about a histogram is that it has to be quantitative data, right? So it's meaningful to have values across the bottom in a bar graph. These are categories: blue, brown, green. This isn't really quantitative data like 2, 4, 6, 8, 10, like we had in our histogram example that we were using. Another way of doing showing your data is pie charts, and that's of course if you're trying to show a breakup of a whole, right? So there's a whole thing, but only 20% were like this or 15% like this. This isn't highly used in scientific data, but it's a possibility. So how to decide what graph to use? So if you're trying to show your distribution of data, and where distribution charts are used to show how variables are distributed over time, helping identify outliers and trends. And you can use histograms or column histograms or line histograms or scatter plots for that. Right? If you're talking about the composition of the data, like we were showing with the pie chart, like the whole thing is made up of these different types, then a column or pie chart is good. If you're talking about comparison data, where you're comparing two data sets, you can use column or bar or line charts. And if there's a relationship, then again, a scatter chart works very well. This site right here is very nice and helpful. I found how to choose the right chart for you. That is also right here in the data. Okay, so that's where I got the information. It was very helpful. Okay, so join us for the next one, the conclusion of the series, where we'll talk about how to use this data that you've grouped, and now you understand the data and you can describe the data mathematically. And now that you can describe your data mathematically, we can talk about how to use that data to prove your hypothesis or verify your engineering design. And we will see you then. Take care. Bye now.